Hello everyone. In this video we will discuss about free expansion. So actually in this first figure you can see this is a container or a cylinder, and this is suppose a piston or partition. So in the left side of this partition, pressure is P1 V1, pressure is P1, volume V1, temperature is T1. So higher pressure is there in the left side, and in the right side it is a vacuum. Okay, so when we remove this partition, so in this second figure you can see the pressure P1 is equal to P2 is equal to constant, means pressure, volume and temperature is constant. So after removing this partition, so here you can say this is the expansion of this volume, this volume. So initially the pressure is P1, volume V1, temperature is T1 in this left portion, and on removing this partition, this the pressure will be constant throughout this container. You can see in this figure. Okay, so here pressure will be decreased, volume will be increased, but it is actually adiabatic container, insulated container, so there is no work or heat transfer throughout this system. So the expansion is taking place in this isolated system, means this partition is removed, this is shifted here. So here the work is not crossing the system boundary, so there is no work done, and it is completely insulated, means del Q is also 0 and del W is also 0 because it is not crossing the system boundary. So here we can say expansion against vacuum. For the expansion against vacuum, the first law of thermodynamics, del Q is equal to du plus del W will be written as dq, del Q is equal to 0, del W is equal to 0, or we can say du is equal to 0, or we can say initial internal energy is equal to final internal energy. Okay, so for an ideal gas, we can say U is the function of temperature only. Okay, so when ideal gas undergoes for expansion process, when ideal gas undergoes for expansion process, the internal energy will be constant, or we can say U is equal to C. Here potential energy is neglected, kinetic energy, change in kinetic energy is neglected, then we can say U is equal to C. So here we can say temperature is also constant, because temperature is the function, internal energy is the function of temperature only. If internal energy is constant, then temperature is also constant. So we can say in free expansion of ideal gas, initial temperature is equal to final temperature, and this does not does not mean that the process is isothermal. Okay, if the internal energy is constant, then temperature will be constant. It doesn't mean that this process is isothermal process, as all the state points are on the same line, hence the temperature reduces and restores due to the friction. So this is actually free expansion, and in the free expansion the work done will be 0, heat transfer is 0, then del u or du is equal to 0, or we can say u is equal to constant. Initial internal energy is equal to final internal energy, and the internal energy is the function of temperature only. So we can say u is equal to c, then T is equal to c. So thanks for watching this video. All the best.